Okay, let me move this. Hold on one second. Let me get to here. Okay, so we're on YouTube Live. Okay, we're saving. So we're on YouTube Live. Oh, I need to shave. I didn't even think about it. It was a. I was not feeling well yesterday, and I feel like I'm just finally getting over the sickness, which is good. I'm glad. I feel better right now. But let's go over this test, and then kind of go over really the questions that Caleb just asked a minute ago. I'll go over those and the structure and everything like that. So, and then I'm going to ask you guys if you have any questions from the homework. It'll go that way. So let's go over the test, and I'm going to go over probably a little more in depth for this first one than I will for the future ones because the instructions won't change moving forward for all 5 tests. So first off, let me show you how to get there. Let me share my screen real fast. Share screen. Let's get this one. Yeah. Okay, so if we go to our class, which is the second 7-week college algebra, on the left, you'll see there's a test button now. And when you click on it, Test 1 College Algebra is in your Blackboard shell. Now, a few things. You do have 75 minutes to take the test. It's a regular class, an hour and 15 minutes, right? So you've got 75 minutes to take it. Once you start, you cannot stop, okay? It forces completion. Yeah, so it is due Thursday at midnight. So actually 11:59. So you've got one less minute than midnight. But Thursday at 11:59 it closes. So it's open now. So today's Tuesday. So really you have like 3 days to take it. You've got today, tomorrow, and Thursday. Now look, we're going to go on with new material tomorrow. So we're going to stay on schedule. But if you want to wait to take that test until like tomorrow afternoon or even Thursday afternoon, that's fine. It's just that we're going to be moving on tomorrow with new material. Now, to see your scores though, you won't be able to see your scores until that availability closes. So when you get done with the test, I know with some other instructors, when you get done with the test, you'll be able to see what you missed right away. I open it up once the due date is up. So once that due date closes, then you can go into your grade book and then view it. If you don't know how to do that, I'll go over that on Thursday or Friday, or I guess Thursday. Well, I guess Monday. I won't see you till Monday after that. I mean, I'll see you tomorrow, but it's like you've got to get a grade. Actually, hold on. I know I'm chatting a lot because I kind of fake took a test. Yeah. So if you want to see your score when you go into gradebook, all the way your what you've made on the test will be right here. You click on it and it'll show you your score, but that will not open up until Friday because it opens up after the due date. There, I mean, just kind of some basic stuff for this test. There's 25 questions. They're in random order. I wish they weren't in random order. It is not Blackboard's fault. I use a test generator software that kind of exports the test and then imports it in to Blackboard, and that's just how it is. If I could change that, I would. So it's 25 questions. They're all worth 4 points apiece. It's multiple choice. I can't think of anything else for the test. Do you guys have any questions about the test at all? So worth 100 points. You know that's in the grade book. You've got 75 minutes to take it. You have until Thursday at midnight to get it done, and it has to be done by then. So if you're working on this test and it is 11:59, it'll shut you off and then it'll put you whatever you score, whatever you've done is done. Okay, so I would get it done before then. I can't think of anything else about the test. A lot of you guys have taken Blackboard tests before. I think it's pretty similar to other Blackboard tests. Here's it going the other way. Okay. So any questions? I think that answered what you were asking me there, Caleb, for the test structure.
Yeah, it did.
Okay, good. So today we're just going to go over review. So my plan today is just to answer any questions you've had. I know the last 2 lectures have been from the class actually earlier this semester, and I really hated to do that to you yesterday because I was not feeling well. Thursday it was just a goofy conference that I had to sit in from 9 a.m. or actually 8 a.m. until noon. So are there any questions from those 2 lectures or from the homework from those 2 lectures. Before I just start on a review for the test, I'll probably have this review a little more in depth than future reviews because I wasn't in class the last 2 days, and I'd kind of, by not having class, I think it's kind of a little unfair to not go a little more in depth in the review process. I gotta trim the beard. Jeez. I don't think I've looked in a mirror in 2 days. Okay. Okay. So let's just start on a review. Let me go to my document camera. Boop. Okay. And I'm going to go through here. And what I'm going to do is I'm going to look at the test. So I'm kind of giving you exactly what's on it. It might seem kind of out of order, but it's when I find something that wasn't really kind of set up that way. I know the very first thing that we went over last week was solving quadratics. So I know that's going to be on the test. So solving quadratics is number 1. This was from 1.5. So I'm going to give you a quadratic equation, and then you can solve it however you want to. I did tell them, and this is just the generation of the test. It kind of tells you how to solve it, but you don't have to solve it that way if you know another way. But it's a little hint when it says, solve this by factoring or solve this by the square root property. You're more than welcome to do that, but you don't have to if you know another way of solving it. But that's definitely going to be in there. Solving will be on it's not the first thing per se, but it's the first thing that we covered in class. And then 2.1 was over really an intro to functions. An intro to functions, the very first thing was really just defining if an equation is a function or not a function, or finding like the domain and range of a function. So hold on, let me see where this is. Yeah. So really stating if a relation is a function. Is a function. And there were a few ways, I kind of present this as in a question. And the first way was for just a group of coordinates. So if I have a group of coordinates, is it a function or not? And then if we've got an equation, those are the 2 that I test you over. I think in the lecture we did like the bubbles, right? If, something probably about pets or something like that, or type of food that we like, something like that. But for testing purposes, it's if a group of coordinates is a function or not, or if an equation is a function or not. That's going to be gone over. And then, oh, wait, you know what? Also a graph. Remember that vertical line test? I test you over that as well. Ooh, so let's get rid of that. So a group of coordinates, an equation, or a graph, if a graph is a function or not, because of the vertical line test. Hold on. I'm just making sure I don't forget something. And then once we knew something was a function, we had function notation. Let's do bigger lines here. And if you go back and look at that section, really it was about, if you were given some function, plugging in, an x value to get the y value, that was the main part from that section. It was really just understanding plugging in an x value into the equation, right into the function notation to get back a y value. Make sure I haven't forgotten anything in this section. 2.2 was the longer section. Okay, wait a minute. Hold on. Okay. That's weird. Okay, and then let's go then now to 2.6, which was over functions, domains of functions. Domain of function equations, right? And I'll tell you, there's two types you're going to have to worry about whenever we have x's in denominator. And then I'll say just square root functions. So I would look back at those, and we went over them in the lecture, right? I know they're on those videos, but those might pop up on the test as well. Okay, so any questions about this before I get to 2.2? I think 2.2 almost, the length of 2.2 is almost all three of these in a way, because it took a while to lecture over 2.2. So do you guys have any questions about anything on these topics? So solving quadratics, finding if a relation's a function given, if we had a group of coordinates, is it a function or not? An equation, a graph, using the vertical line test. And then function notation. If we've got, like f of x equals whatever, and I give you an x value, finding the y value. And then the domain of function. So, if we've got x's in the denominator, that was a red flag. And then the square roots.
I understood the group of coordinations and the graphs, the vertical line test, but I didn't really understand the equation too much. I understood it, but it was a little unclear on some parts.
So do you want to look at an example of one?
Yeah, that'd be cool.
So let's say I gave you an equation. X equals y squared. And I ask you, is this a function? Right? Well, you got to think of this as input output. So I'm going to plug in a number. Let's say x equals 16. Doesn't really matter what number it is. And you're going to plug that into, now it's always an x value. You're going to plug it in. So you get x squared equals y squared. You're going to plug it into the equation. And if you wanted to solve this, now we're having to do the square root method, which is in 1.5. You take the square root of both sides. And don't forget to add the plus or minus. And we know the square root of 16 is 4. So you get plus or minus 4 equals y. So look, we plugged in a single x value, and we got back two y values. Y equals 4, and y equals -4. So because this happened, we do not have a function. This is like two coordinates, or this is saying if I graph this, two of the coordinates would have been 16, 4, and 16, -4. Therefore, this is not a function, right? 16 can't go to 4, and it can't also go to -4. So because I plugged in a single x value and got back two y values, not a function.
Well, what determines that it gets two y values?
What do you mean, Caleb? Hold on, I got to turn you up a little bit. I can barely hear you.
What determines if it gets two y values?
Well, when I took the square root, it was a plus or minus, right?
Okay.
So let's look at one that doesn't have that going on, okay? Let's say I'm going to flip the square around. X squared equals y. And I'm going to plug in the same x value, 16, okay? I've got 16 equals y, or 16 squared equals y, right? Well, 16 squared is some big number. I guess I'll just pop in my calculator. 16 times 16, I get 256. Notice when I did this, I don't have a plus or minus or anything like that. Do you see that, Caleb?
Yeah.
So I plugged in a single x value, and I got back a single y value. So the only coordinate is 16, 256. So this would be a function. So it's not that there's any particular thing that causes two y values. It's that you have to roll with the equation to see if it creates two different y values.
Okay.
Yeah. But there's not some like nice rule. I think is that kind of what you're asking me? Like, hey, what's the rule?
I suppose, yeah.
Yeah. It's not like some nice cookie cutter rule that I can give you. It's that you've got to kind of flow with the equation because they might look different, right? You got to flow with them and say, hey, would this create two y values?
So why did you put plus or minus?
Because when you you need to go back to section 1.5, Caleb, and look at solving quadratics. It's going to be on the the test anyway. Solving quadratics by the square root method. Solving quadratics by the square root method, and you'll know why I put that plus or minus there.
Okay.
Yep. And that will be on the test as well. That's part of section 1.5. 1.5. Okay. Any other questions before I go on to 2.2? We've got plenty of time. Okay, 2.2 really is kind of the biggest chunk of the test, I'd say. Well, maybe not. I mean, it's kind of scattered across, but 2.2 just has a lot of topics going on. So 2.2. I'm going to open up the book just so I kind of get them in order for you. So 2.2. It was my favorite titled section. Yeah, that's right. And I didn't get to tell that joke in this class because I was sick. More on functions and graphs. First, we went over increasing and decreasing. Really, I'll tell you, 2.2 is kind of like describing functions. I feel like 2.1 was more about introducing them and defining them. 2.2 is more about the description of functions. So first, it went over increasing, decreasing, and constant functions. So increasing, decreasing, constant. Now I'll tell you, on the test, it's going to be multiple choice. So I'm just going to give you a graph, and I'm going to ask you, hey, where is this function increasing, decreasing, or constant, right? So it's very kind of straightforward. And actually, I think I use the same graph for all three. So I give you a graph, and I say, where is it increasing? And then like the next question is, where is it decreasing? And the next question is, where is it constant? On a regular test, it would be an ABC question, right? Where like, here's the graph, A, increasing question mark, B, decreasing, C, constant. But for this one, it's just increasing, decreasing, and constant. Okay. Let me make sure I'm not missing something. Now, I did not bring up the relative min or max on the test. It's one of my least favorite things for some reason. And I'll tell you why it's my least favorite. I wouldn't teach it the way Dr. Blitzer teaches it. But it's one of those things where I'm not going to tell you to put it on here because it's not on the test. But it's something that you kind of need to grasp for later on. But I'll go over it again for how we need to know it. So don't worry about the relative min or max for the test. Just realize it's the high points and the low points. And then the next thing your book goes over is even odd symmetry. Even or odd symmetry. I'm going to look and see how I asked this with an equation. So I give you a function equation, and I ask you, is this even, odd, or neither? Okay, even, odd, or neither. So whenever you get to that question, let me make sure I'm not asking on a graph. Yeah, I give you a graph as well. So I'm going to give you an equation, a function equation, and ask you, is it even, odd, or neither? And then I'm going to give you a graph and ask you if it's even, odd, or neither, okay? Remember, even was just symmetric around the y-axis. Odd is symmetric around the origin. Okay, even symmetric around the y-axis. Odd is symmetric around the origin. Then your book goes over, piecewise functions. Ooh, not piecewise. Piecewise. So piecewise function, I'm just going to give you a piecewise function, and then I want you to evaluate it. So if I gave you just give you a piecewise function, then ask you, what's, or actually I'll tell you what f of x is. Let me actually kind of show you how I'm going to ask that one, because I know in the lecture, I go a little more in depth than how the test is actually. For this example, it would be like f of x equals, let's say 2x minus 1, if x is less than or equal to 2, and then x squared plus 3 if x is greater than 2, okay? So I give you a piecewise function. Look, we've got this equation if x is less than or equal to 2, this equation if x is greater than 2. And then I'm just going to ask you, well, what's f of, let's say, negative 3? And you've got to decide, okay, wait, remember, this is the x value. Negative 3 is less than or equal to negative 2. It's not greater than 2. So therefore, I've got to plug it into this equation. 2 times negative 3 minus 1. So we get negative 6 minus 1, and we get negative 7. Okay? So it's not the hardest question. You just have to understand that this x value determines if we use this first equation or the second equation, right? We're going to use the top equation if x is less than or equal to 2, which was true for us because it's negative 3. Or we're going to use the bottom equation, the second equation, if x is greater than 2, which was not true for us because x is negative 3. Okay?
And there are some equations like that on the test?
Yep.
Okay.
It was the last lecture, 2.2b, actually, went over went over the piecewise function.
Could you give an example of the increase and decrease in constant of functions? Like,
yeah, give me 1 second. Let me go over one more thing and then we'll get there. So the other thing is, oh, actually, no, I think we're done. Vertical line, yeah. Just making sure I've hit all the topics here, Kayla. Yep. Yeah, okay. So let's do increasing, decreasing constant. So,
and if you don't mind, maybe a couple examples of quadratic equations, like maybe like examples of like the really like strange ones, if you know what I mean.
I'm not sure what you mean on that one, but I can give you a few different examples of them.
That'd be helpful. Thank you.
Yeah. So let's look at an example of this. So let's graph. Let's say we have this nice quadratic graph here. Something like that. Okay. And I'm going to ask you, I'm going to put it all together here. Increasing, decreasing, and then constant.
That would be increase, wouldn't it be?
So if you watch the lecture, you'll see that I talked about going left to right. And I think I drew a guy kind of on a roller coaster, right? And so when he's going left to right on the roller coaster, at this point right here, he's decreasing. And then when he hits this bottom, he's going to turn and he's going to increase. Now, we always use X domain values to signify where you are increasing or decreasing. So if you think about this, if he's riding the roller coaster, or she, doesn't matter. He's riding the roller coaster. He's going down forever until he hits this vertex. This guy's right here is called a vertex. So until he hits this vertex, and then he switches. So this graph actually is increasing, or it doesn't start increasing until x equals -1. But then look, -1 to infinity, this guy is increasing. Okay? This guy's increasing. And then look, so decreasing. Well, it turns out where I drew him right there, he's decreasing, right? He's going down the roller coaster. So from -infinity to -1, he's decreasing. Now, this one does not have an example of constant. A constant would be if you flatlined. So if there's no constant, we're going to do a circle with a line through it. That means there's no solution. That's just a fancy way of saying no solution. Okay? There's no solution here.
So why is it negative? Why does the decrease start at like negative infinity? Wouldn't it be positive?
Because you always use the x values. And from negative infinity to -1 here, we're decreasing.
Oh, my bad. Never mind. I see now. Gotcha.
That makes sense? Yeah, give me 1 second. Okay. Now, a constant example, which think of this as another graph here, so I don't have to draw another graph. Let's say we had one that did this. Something like that. Oh, gosh. Guys, give me 1 second. I'm having to deal with something in the back here. It's being kind of glitchy. 1 second. Actually, I'll ask you this one. I want you to answer the same question. So increasing, decreasing, constant. Okay. And I'll get to those. Try those real fast. I am dealing with Blackboard issues. Okay, so this one, again, if we think of the guy on the roller coaster, at this point, he's increasing, right? So now it goes down forever to the left. So that means actually it's going to go up forever. You got to think going left to right. It's going up forever until you get to 1, 2, 3 here. So it's increasing from negative infinity. Well, let's just write it above it. Negative infinity to +3. It's increasing. Okay, that's increasing. This one's never decreasing. It's going up and then it flatlines. So it's never decreasing. Constant though, yeah, from 3 to infinity, it's constant. Okay, 3 to infinity, it's constant. So that's the constant kind of ran out of room there. Okay, so that shows you all 3 versions of that. Okay, all 3
I think the one thing that's kind of like tripping me up is just like when you label the point at where it like flatlines where it stops and then it like the constant starts, you put 3 infinity instead of like +3 and +1 because that's the exact coordinate. I don't know.
These aren't coordinates. These are x intervals, bud. That's not a coordinate. That's an interval on the domain. Okay. It looks like a coordinate because it's parentheses and commas, but that's actually a domain these are intervals on the domain. So this means from negative infinity to 3, right? And then this means from 3 to infinity. So yeah, I understand what you're talking about, Caleb. It does look like a coordinate, but we don't use the y value when we're talking about increasing, decreasing, or constant. We just want to know, really the question, and I don't know why your book doesn't say it like this. The question should be, over what domain values is the graph increasing, decreasing, or constant? Okay.
Well then wouldn't the increase be -3 to +3?
-3 to +3.
Yeah, because it goes down -3 and it's on that point, or it's not on the point, but it's near
Are
it.
you talking about like over here?
Yes.
No, those arrows mean it goes forever.
Oh, okay.
Is that what you're meaning? So like because this goes forever this way, right?
I just saw a point, like you didn't put an arrow there, so I guess.
Yeah, no, it was just kind of faint. Yeah, that arrow means it goes forever. And yeah, actually, if it stopped there, it would be -1 to 3, right? Yeah, -1 to 3, which pops up in the homework. The homework does a lot more kind of that kind of stuff.
Oh, my bad. Okay, yeah, now I get it.
Yeah. Is it
You're
clicking?
basically kind of you're using the X value. You're using the X value like part of it, not the Y value. You're using that as a guide to see where like it's going. Okay.
Yeah, you are exactly correct.
I gotcha. My bad. I'm sorry.
No, that's okay. That's you're just the only one asking. I promise. You're not the only one that wasn't getting it. I promise. Okay. Any other questions about that? I'll go over some good questions from the 1.5 section. But are there any questions now on this part? I don't mind answering anything. Okay, so I'm just going to give you a few of these, and then I'll kind of show you why they're different. Actually, I'm going to ask you, because the test does this, and I didn't actually realize it did it for you, which was kind of nice. So to solve quadratics, we went over 3 main ways to solve quadratics. First, and this will be the first example, is solving by factoring. So if I gave you, let's call it just number 1, 2x squared minus x plus 3 equals 0. Actually, you know what, guys? This has to be, let me rewrite this one. 2x squared minus x minus 3 equals 0. So that's solving by factoring. So I want you to solve this by factoring. And I'll tell you, on the test, it's not that you have to solve it by factoring, but you have to know how to factor, because we're going to be factoring throughout this entire semester. Second, solve by the square root method.
This is exactly what I want.
So 2x squared minus 14 equals, let's say, negative
I'll do that tomorrow.
32. And then third, and I'll probably solve this on another piece of paper, but let's say solve by the quadratic formula. X squared, let's say minus 3x minus 5 equals 0. So try those 3. I'll give you a few minutes. Try those 3. And I want you to use each method, because that's how I'm going to answer them with the 3 different methods. Okay, so let's do this one. So 2x squared minus x minus 3. I've got to use the AC method on this. 2 times -3, that's -6. To get -1, I would use -3 and 2. So this would be 2x squared minus 3x plus 2x minus 3 equals 0. Remember, we split apart the negative x into those two terms. Parentheses are on the first two and last two. I can factor an x out of this one. I get 2x minus 3. I don't want to change this one, so I'm going to factor out a 1 because they match. These two match, and I get 2x minus 3 times x plus 1. Set those equal to 0. I'm going to have to finish this one over here because I don't have a gap. 2x minus 3 equals 0. Add the 3, divide the 2. So you wind up with x equals 2/3. X plus 1 equals 0. Subtract the 1, and I wind up with x equals -1. And again, if you're like, oh my God, you're going way too fast, go back to section 1.5. The lecture on 1.5, we went over how to solve by factoring. But this is called the AC method, if you want to look it up on YouTube. AC method or the bridge method or solving or factoring polynomials by grouping. That's all three the same thing. So now the square root method, the goal in the square root method, or when you could use it really, is if you could get x squared by itself. So I'm going to add 14 to both sides. 2x squared equals 32 or -32 plus 14, so -18. Divide by 2, and I get x squared equals -9. Now again, this is when we have to do the plus or minus. If we take the square root, we have to attach the plus or minus. So we're left with x by itself. Now the square root of -9 is 3i, right? But you have to have a plus or minus. So it's plus or minus 3i. Now, on the test, if you have more than one solution, it's going to split it into two answers and write it as set notation. So it's going to write it like this. Squirrely bracket 3i comma -3i. And I believe the book does anyway, but I want you to be aware of that it splits it up in that manner, where if it was a written test, I wouldn't care if you wrote plus or minus 3i. But for the software, the test generation software, it writes in that manner. Okay, this last one I'll have to use another piece of paper. But let's say we've got 2x cubed minus 3x minus 5. And I actually use the quadratic formula. Well, a equals 1, b equals -3, and c equals -5. So x equals -b, so +3, plus or minus the square root, b squared minus 4 times a times c all over 2 times a. Now underneath this radical, we get 9, right? -3 squared. Minus 4 times 1 times -5, so that's a plus 20. So we wind up with 29. So we get x equals 3 plus or minus the square root of 29 all over 2. Now, I can't simplify 29. It is a prime number, right? So we're done. Now, again, if this was just a written test, I'd be okay with this. But your book is going to split apart those two answers into 3 plus the square root of 29 over 2 and 3 minus the square root of 29 over 2. Okay?
The test is going to do that too?
Yeah, the test does that. Yeah, that's why I'm putting that on there, Caleb. Yeah, the test does that. And it's one of those, like, it's the proper math thing to do kind of things. But just for efficiency, we usually don't do that. Okay. Any more questions? You got me for about 30 more minutes. You guys have any more questions?
Could you go back to the outline, where you like listed all the stuff that would be on the test?
I just threw it away. Did you write it down?
No, but it's okay.
You can rewind it.
Yeah, I could.
But yeah, no. I know, we've got 1.5 is on quadratics. 2.1 is really just the intro to functions.
You explained it pretty well, though. I got it now.
Okay, good. And I'm telling you, go back and watch those lectures. I don't make tests that are, I try not to make tests where a student feels like it's just curveballs. That's not my goal. My goal is just to make sure you understand it. And I'll tell you this first test, the first test isn't necessarily that's the easiest or hardest. The first test is usually just finding out how I test, right? But I mean, you got a lot of pros going on because it's multiple choice. You know, you can use your notes. It's not a big deal. Just realize if you don't know it going into it, you're not going to finish. So I don't mind if you want to use your notes to remember the formula or something like that. That's fine. But realize you're going to run out of your hour and 15 minutes if you think you're going to go into this test and just learn it as you're taking the test. It's that won't happen, right? You'll have to understand the content, and then maybe use your notes as you kind of go, or ones that you kind of get stuck on. Use your notes for those. But if you have to use your note for every single question, you won't get done in time. And not that was purposeful. That's just how. I mean, in a regular test, you wouldn't be able to use your notes if you're in class. So, kind of giving you one thing. This has been such a crazy semester. That's my gift to you, is being able to use your notes on tests. Okay. Okay. Do you guys have any other questions? I don't mind sticking around for a little bit in the background. If you think of something, that's fine. But if not, you are free to leave. I'm going to stop the YouTube so it doesn't